Look at a deep red Indian chicken bhuna, a simmering Thai green curry, and a thick, sweet Japanese curry. These dishes are culturally and visually distinct. A traditional Thai stew relies on fresh herbs and coconut milk, while an Indian gravy builds on dried, toasted seeds and clarified butter. Their ingredients and flavor profiles sit on opposite ends of the culinary spectrum. The common name curry actually describes a 4,000-year-old thermodynamic formula for flavor extraction. Applying this chemical perspective reveals how a single scientific process allowed a few foundational aromatics, like turmeric, ginger, and garlic, to adapt to vastly different cultures and climates. Spice flavor compounds like cuminaldehyde and piperine are hydrophobic. They repel water. Dropped in boiling broth, these molecules stay locked inside, leaving the dish dull. Since they're lipophilic, you must bloom them in a lipid medium, like oil or ghee, between 120 and 150 degrees Celsius. This chemical necessity is the foundation of the traditional Indian cooking technique known as bhuna. In a bhuna, cooks take a paste of onions, garlic, ginger, and spices, frying it until the vegetable's water content completely evaporates. You know the process is working when the oil physically separates from the solid mass, a marker known as tel chutna, or oil releasing. Pushing the temperature past the boiling point of water and into the high heat realm of hot fat triggers the Maillard reaction. The amino acids and sugars rapidly break down and recombine, generating the savory complexity and signature dark color of the dish. The intense flavor of Indian curry exists because cooks figured out how to manipulate the boiling point of water against the smoking point of fat. Thai curries, or gang, seem like an exception. They are wet, highly herbaceous, and flooded with coconut milk. On the surface, the cooking styles look unrelated. But the first step of making a traditional Thai curry involves boiling down coconut cream until it cracks. By evaporating the water content in the cream, the cook forces the pure coconut oil to separate and rise to the surface. This creates a pool of high-heat fat right in the pan. The Thai cook then fries their fresh herb paste directly in that cracked coconut oil. Despite the different plants and fats, they are executing the exact same lipophilic extraction science as the Indian cook. This mastery of spice and fat dates back to the Indus Valley civilization. Archaeological evidence shows cooks used garlic, ginger, and turmeric by 2500 BCE. Millennia later, the British Empire encountered this culinary science, but were unable to replicate the exact technique. Instead, they commodified the aromatic profiles into simplified curry powders, exporting them globally. Meanwhile, hundreds of thousands of Indian indentured laborers brought the true flavor extraction techniques to the Caribbean. Working in Trinidad and Jamaica, they adapted the science, swapping out traditional fats and extracting the heat of local capsicums like the Scotch bonnet. During the Meiji Restoration, British traders introduced their version of the dish to Japan. Local cooks adapted it into kare raisu, a milder, starch-thickened comfort food that quickly became a staple of Japanese home cooking. A bowl of curry represents the culmination of a 4,000-year-old chemistry experiment, continually adapting to new ingredients and kitchens across the globe.